initiative was designed. Represented body is rental monitoring and inspection.
Hello, good afternoon, everyone. Thank you for joining in. I would like to claim your indulgence. Let's wait for about 5 more minutes so more people can join us for the seminar. We'll start by 4:10 on the dot. Thank you again. Okay, good afternoon, everyone. Thank you for joining us for our CPDP program scheduled for the month of February. We appreciate everyone. Good afternoon, everyone. Thank you for joining us for our CPDP. Hello, can you hear me now?
Okay, Ada, I can hear you.
Okay, yes, please. Okay. Please carry on, Vice Chair.
I'd like to recognize our fellows in the house. Thank you so much, Saz and Maz. We are grateful for joining us and your continued support to all the full members, students, every single person. Behind when we talk about stuff.
We cannot hear you.
Okay, can you hear me now? I'm so sorry, my network kept bouncing.
Yes,
Okay,
we can
all
hear
right,
you now,
fantastic. Thank
loud
you
and
so
clear.
much. Okay, all right. So, going to jump into it. I'm going to hand over to the GS now for her to read the bio of our esteemed guest, and then she can take over. Ada, thank you.
Okay, thank you very much. Our topic for today is green building practices. Green building practices, sustainable design strategies. And our speaker is architect Mary Morane Dasat. Architect Mary Dasat is a graduate of Istanbul Technical University, Istanbul, Turkey, and Heriot-Watt University, Edinburgh, Scotland, where she developed a strong academic foundation in architecture, sustainable design, and environmental performance within the built environment. She's a professional interior designer and sustainability consultant with cross-regional experience in Nigeria, Turkey, and the United Arab Emirates. bringing an international perspective to sustainable and inclusive design practices. She holds several globally recognized sustainability and performance-based credentials, including WELL Accredited Professional, WELL AP, Lead Green Associate, DGMB International Consultant, and ESG Manager, EDGE Expert, EDGE Auditor, and EDGE Faculty. These certifications reflect her technical competence in green building rating systems, environmental benchmarking, health and well-being strategies, resource efficiency, and ESG integration in the built environment. Mary is an active member of the International Association of Accessibility Professionals, IAAP, the Nigerian Institute of Architects, NIA, the Interior Design Association of Nigeria, EDEN, demonstrating her commitment to ethical practice, accessibility standards, and continuous professional development. Her areas of practice include sustainable interior design, green building certification advisory, ESG strategy integration, inclusive and accessible design, sustainable material specification, and environmental performance optimization. She currently serves as principal consultant at Enable Green Consulting and MDAD Atelier Nigeria Limited, both based in Abuja, Nigeria. In these roles, she leads sustainability advisory services, manages green building certification processes, and delivers environmental responsible design solutions that align with international best practices and measurable sustainability outcomes. Yeah, so I would like to welcome you, Mary. Thank you for joining us.
Thank you very much. Good evening, everyone.
Okay, good evening. Would you want to share your slide or do we go ahead? Okay.
You can go ahead.
Okay, thank you. Okay, Mary, you can carry on, please. Thank you.
All right. Good evening once again, and thank you all for joining this session. Like I've been introduced, I have cross-regional experience in sustainability consulting and green building practices, and I hope that I'll be able to impart one or two knowledge this evening. So you can go to the next slide, please. Okay, why green buildings matter. So I'm sure we're all currently living inside a building, right? Everybody's inside an enclosed space. Nobody's on site, even though I know architects, we know how to multitask. Some people might be on site and also joining the session. So research has shown that human beings spend 90% of their time in buildings, right? 90% of our times in buildings, either at home, at work, or places of leisure. And research has also shown that buildings is a major contributor to greenhouse gas emissions. Greenhouse gas emissions are those emissions that, greenhouse gas emissions are emissions that are catalysts to global warming and climate change. In Lagos specifically, we have also issues of high urban migration. We also have issues of flooding, especially in the island, Lekki, Victoria Island. We have mass urbanization, which leads to high demand for housing. So there's a lot of construction activities that are going on, which also leads to heat island effect, whereby there's a lot of cutting down of trees, clearing of bushes to make way for development. And then the way we have been developing has also been very resource intensive, in the sense that there's massive extraction of raw materials. These raw materials undergo industrial processes to transform them into building products. And all these have negative environmental impacts. And this negative environmental impact is what is leading to what we are currently experiencing at the moment. We also have high population explosion. So Nigeria, as about 10 years ago, was about 160, 70 million. And now we are about 220, 30 million. And this population is going to continue to expand. With more population, there will also be more demand for housing. So why green buildings matter? Because if we continue the way we have been operating, it's not going to be sustainable. We also look at the cost of rising cost of energy, unreliable grids, and dependence on generator. Our public power supply. I'm still on the first slide, please. Thank you. Our public power supply, if it was reliable, it's actually from a renewable source, which is hydro, mostly. However, because it is not reliable, a lot of individuals, organizations have to back up this power with diesel generators mostly. Recently, we've seen a rise in natural gas, CNG power generators, as well as renewable energy. So rising energy costs, we've heard of the bands, distribution, band A, band B, band C, and it's becoming really, really expensive for us to run our buildings, our businesses on such very high tariffs. So these are the factors that that are pushing people to look for alternatives. And that's why green buildings matter. Next slide. Okay, so let's look at the core principles of green buildings. If I'm to ask, and I would want this to be as interactive as possible, what is a green building? If anybody wants to answer, they can either raise their hand so that the admin can unmute them, or you can type in the chat and then admin can help me read it out, please. No one wants to try? There's no penalty for wrong answer. Okay, a green building, basically, in the most fundamental definition, is a building that uses less resources, right? And has less negative impact in the environment. So the core principles of green buildings, we have climate responsive design, reduce carbon footprint, resource efficiency, indoor environmental quality, and life cycle thinking. And why do these principles matter? Because sustainability has to be embedded in the design from the point of conception, okay? You look at, when you do your site analysis, or if the site has already been determined, you look at the best ways of designing in context to the location. So sustainability starts from the conception of the building. Then you now look at how the climate affects whatever you're designing regarding the function. We're now looking at also carbon footprint of the building. So the carbon footprint of the building, we're looking at ways to reduce the carbon footprint of the building, and this could be either in embodied carbon or operational carbon. And what is embodied carbon? These are carbon emissions as a result of the building construction activities. That is it, from the resource extraction to manufacturing and construction on the site, or operations of that building. So how can you reduce the carbon footprint of that building? Resource efficiency, construction activities is one of the major contributor of global waste. And so how do we build to reduce waste? Then we're looking at indoor environmental quality, comfortable indoor temperature, acoustics, as well as the negative impact of construction materials and finishes on the health. Then we're looking at life cycle thinking. So core principle of green building is life cycle thinking, in the sense that when clients are considering going or developing a project development, they only think of the initial cost of that project. They don't look at the life cycle cost beyond that handover of the project when it is completed. So life cycle thinking is one of the core principles of green buildings, whereby you look beyond the cost of construction, you look further to the lifespan of the building and consider repairs, maintenance, etc., and even the deconstruction or demolition of that building and what can be salvaged from the building afterwards. Next slide, please. Okay, so we also have, as a result of the awareness or growing awareness of green buildings practices, we have also green building certifications that are also becoming popular. On the screen, we have four examples of the popular ones that are related to our context, that is Nigeria and Lagos, where the target audience are today. So we have EDGE, which is an acronym for Excellence in Design for Greater Efficiency. EDGE is an innovation of IFC, which is a member of the World Bank Group. And the reason for the creating EDGE was for them to scale green building adoption in the emerging markets, or what we know as the developing countries. So EDGE is very popular in Latin American countries, Africa, both the northern region and the sub-Saharan Africa, South Asia, and it's beginning to also become increasingly popular in some European countries as well. Then we have LEED, Leadership in Energy and Environmental Design. It's an innovation of the United States Green Building Council, and it's one of the most popular green building certifications that is out there. And LEED has, it assesses projects based on multiple categories. So while EDGE focuses on the most impact, so like I mentioned, it was created for developing countries, otherwise known as emerging markets. And the challenges for those markets are very, very, EDGE was created to target or to mitigate, to overcome the challenges that are existing in those markets. And that is why EDGE only looks at efficiency in energy, water, and embodied carbon in your materials. Whereas LEED has about 8 to 9 categories, if you include innovation, and they cover beyond energy and water and materials. They look at indoor environmental quality, they look at the site, biodiversity, and so many other factors. Then we have BREEAM. BREEAM is a Building Research Establishment Environmental Assessment Method. It is a product of the British Research Establishment, that is BRE. And it's one of the first, it's the pioneer green building certification globally. It is majorly used in the UK and some parts of Australia, and then one of 2 international projects here and there. Then we also have the DGMB from the German Sustainable Building Council, and it's also the local adaptation for Nigeria by the Green Building Council of Nigeria. So let's move to the next slide. Okay, so let's look at the business case for green buildings. Green buildings, like I mentioned earlier, are resource efficient. They help reduce your operational costs. They offer competitive advantage in the sense that when you're looking at the value of the property, green buildings will mostly factor in other climate resilience measures in the design and construction. So the property value increases, and then in climates where they have incentives for accessing finance, with a green building certification, you'll be able to access better financing, either for the construction of a building or for acquiring of a home that's under green mortgages. So now we're going to look into eco-friendly materials. So I spoke about embodied carbon in materials, and I did mention that embodied carbon is the carbon emissions related to the resource extraction, transportation, manufacturing, and also installation of those materials on site. And this embodied carbon, is significant in the sense that if you look at the life cycle of a building, embodied carbon contributes about 13% of the overall life cycle carbon of that building. And that is why it is critical for us to be very intentional when we are selecting or specifying materials and ensure that we specify materials that are less carbon intensive. So we're looking at sustainable material selection. We've spoken about low carbon, low embodied carbon materials. Then we're also looking at durability. Under eco-friendly materials, there are a lot of materials out there. And if we look at even our traditional building practices, we have most of our traditional buildings are actually green, in quotes. The issues with them is that we didn't scale or upgrade those traditional practices we had, those vernacular ways of building, and we abandoned it and adopted new ways that required more advanced industrial processes. And that is why we're currently going through what we're going through. And then you can also see that these materials are also becoming very, very expensive. I mean, if you want to build now and you consider cement, the cost of cement, that alone will just make you think again. So we need to look at alternative materials that can also offer us as similar performance in the sense of durability or even higher, better. Then under sustainable material selection, we're also looking at local sourcing. It is one thing for you to specify or select materials that are sustainable. It's another thing to select or specify materials that are sustainable that are coming from a very far distance or a far location. So for example, you want to build and you've seen on the internet that there are some block or eco-friendly blocks that are being made or manufactured in either Indonesia or Philippines. And because you want to use it in your project to make your project eco-friendly, you go ahead and import it. So now the material may be eco or sustainable. However, there is a increased carbon footprint as a result of transportation, where you have to now bring in those, shipping those materials from far away. So it's good for us to look within our environment. And it also offers an opportunity for architects to go into this will I say design or specification, manufacturing, maybe building materials manufacturing, because we have a lot abundance of resources, raw materials that we can just sit down and tweak one or two things and you come up with a product. Even all these products that we import from China or Turkey, Europe or America, it took their own designers or their own engineers ingenuity to come up with those products. So I believe that we can also sit down and look at, there's a lot of research out there. I mean, someone was asking me to do a PhD. They said, I can't, what am I adding to the knowledge? There's a lot of knowledge out there, and we just need to find a way of transferring those things from the textbook into practice. So you don't even need to go and do research. Find a research and then see how you can apply it and bring out a product. Recyclability. Sustainable material selection also considers the recyclability of that material. And in Nigeria or even globally, now there's a growing increase in the trend for materials that are installed mechanically, because it's easier for you to salvage those materials at the end of the life of the project. It's easier for you to unscrew them and then reuse them, or just do a little bit of upgrade, refurbishment, and then use them in other projects. So recyclability is very key in sustainable material selection, because when you look at, let me give an example. So I do a lot of renovations as an interior designer, and one thing that pains me is when we have to break tiles. There was a project that we were doing and the tiles was installed and this client went somewhere and saw another tiles and he just came and said, remove all the tiles. And tiles are mostly installed with cement, right? So there is no way of salvaging those materials. Those materials are going to waste, apart from even the financial loss, and then those things are going to go into landfill. It's also going to have a negative impact on the environment. So I was just thinking, are there no ways of us having tiles that can be mechanically installed? And I was doing my research and I found out, even though not for wet spaces, but for external facades, there are actually systems now, just the way we have the aluco bonds that are screwed on some profiles. Now there are also tiles that you can also install that way. So when you're thinking of, when you're doing your material selection and you're considering recyclability, you consider those factors. Then environmental certification. So there are EPDs, environmental product declarations. Those are additional checks to verify that products or the materials we are selecting or specifying in our projects are sustainable. And right now, a lot of products, local products in Nigeria, even local manufacturers, I'm not sure many of them have EPDs. And for example, if you're working on a project like a LEED certification project, you would need to show some of these certifications. So it's also an opportunity for architects who have a little more time or who want to explore to go look at how can I become an environmental product. They call it an EPD certification or something like that. You can Google it, or I'll drop the link with the chapter rep and they will share it afterwards. So that is for sustainable material selection. Next, we have life cycle assessment. So life cycle assessments also is a step further, similar or a step further from environmental product declarations. And those life cycle assessment also look at the impact of those products from extraction. So there's something called cradle to gate and cradle to grave, and then cradle to cradle, right? So cradle to gate is the assessment that is done from extraction to transportation to manufacturing up to the delivery at the production and construction site. Cradle to grave includes the installation on the project, the use, and the end of use. So grave is burying it when it's done, you're trashing it. Then cradle to cradle, which is a factor now that is becoming more popular as a result of also circular economy being very key in resource efficiency. Cradle to cradle has life cycle assessment, looks at the recyclability. Instead of you to just throw it back into the earth or throw it in a trash those materials at the end of their life, how can you salvage those materials and then either transform them or use them with less carbon transformation or impact. And next, under LCA, we are looking at operational energy impact. The operational energy that is being used in a building, research has also shown about 50% of the energy used in a building goes to cooling, supplying of for air conditioning. And so you consider the life cycle cost of that building, and that life cycle cost looks at the cost of operating that building. So beyond the cost of building it, you're looking at your utilities, cost of operations, and those, when you consider the life cycle cost, last 2 weeks, I was with one of my bosses, and he was telling me of how a client of his that he designed a hotel for called him and was crying and saying, it's like I did this hotel to just be giving money to the diesel dealers, right? Because first of all, the power grid we know is not reliable, so he has to run the hotel on diesel. Diesel has become so expensive. If he increases the cost of the accommodation, he doesn't get any customers. So he's just within the he found himself in a very hard place, and he's thinking, do I just shut down this business because it's like money is coming in and it's just going directly to service this thing. So when you're designing, or when clients come to you to design as an architect who wants to now embed sustainable building practices, you now go beyond thinking, delivering aesthetics, beauty, and all those other things, meeting the functionality, but consider the operational cost of that building and even the life cycle considerations of that building. Maintenance cycle also, so specify products that are long lasting, not products that after you hand over, after the defect liability period, the doorknobs start falling off, or so many other things. We have a lot of very poor, low quality materials flooded in the market. So it is one thing for you to specify a product, it's another thing to make sure that those products are installed on the project. And clients are always very cost conscious, but if you let them see that this faucet that we are buying, yes, there is one that is in the market that is going for 20,000, but if you buy this one that is 80,000, you're sure for guaranteed that for the next 15, 20 years, you're not going to replace it. As against that one, they are putting for 5,000, and every other 6 months, you are replacing it. By the time you calculate the total number of replacements of those materials over the life cycle of the building as against more durable materials, then you are able to convince your clients to spend that extra upfront in order to be relaxed when the project is completed. Then I've spoken of end of life potential of even the building. So I was in Lagos 2 weeks ago, and I was passing through the coastal road, and I saw a lot of the projects that were demolished. And I was just thinking of, is it possible for us to design in a way that whenever government wants to demolish, we can just uproot or deconstruct that building without so much loss of revenue? So it's also important for us designers now to start thinking of creative ways to design and build houses. Under eco-friendly materials, I made reference of rammed earth and stabilized earth bricks. This is it's gaining prominence at the moment. In fact, I'm currently doing a research for a project and we're considering how to use rammed earth for the building. And rammed earth has low embodied energy because it's not going through any industrial processes. It has high thermal mass. It's locally available and very cost effective. And from the research I've done, it also has load bearing properties. In fact, I've seen a multi-story building in France that was built with rammed earth. In Nigeria here, we have an example in Benin City. The Moa Museum was built with rammed earth. Then we also have a few more projects across Africa. There's a sports center in Ghana that was built with rammed earth. I know David Ajay mostly and Francis Carey are promoters of natural materials. So if you're interested in learning more, you can Google those people and look at the projects that are out there. There's also stabilized earth blocks. The stabilized earth blocks are different from the normal burnt bricks that we are familiar with, in the sense that they don't go through any oven, right? There's a certain percentage of cement. I think from my research, it's about 5% of cement. If the clay is not so good, or if it has a lot of if it has a lot of impurities, then it can go up to 10%. So the earth is stabilized with a little bit of cement, and these bricks are sun dried. So sun is a natural renewable energy. You're not putting it into any oven. You're not burning fossil fuels for the production of those bricks. So stabilized earth bricks are very renewable. They are very eco-friendly. They have zero negative environmental impacts, apart from the areas where you extract those the raw material, that is the laterite or clay that you're using. So it's also important for you to consider where your materials are coming from. There's a project that was built in Spain. It is a municipal swimming pool. They used rammed earth for that construction, for that building. And the majority of the earth was from the excavation of that pool, right? So you're not cutting away anything from your site to a landfill. So those are ways of being sustainable. So ramp earth is also cost effective, I mentioned, because of the minimal use of cement. Then we also have low carbon concrete solutions. The cement is a major polluter of the environment, both in the extraction of materials and even in the manufacturing. And even when we move to site, a certain percentage of cement is wasted on site. So are there low carbon concrete solutions available? Yes, there are. And there are supplementary cementitious materials. There is something you call fly ash that is added into the concrete mix to reduce the percentage of concrete cement in the mix. There is ground granulated furnace slag. There are different additives. And I know that last year or 2 years ago, I learned that Lafarge also launched a green cement. I have not seen it in the market, but I did hear about it. And I'm curious to know how far they are going to push that into the market. There's also something called geopolymer concrete, as well as the use of recycled aggregates. So that is it for the eco-friendly slide. Okay, I just need to add, in addition to under the eco-friendly materials, we should also consider engineered wood. Engineered wood, I know in Nigeria, we actually currently have a deforestation problem, but that's because we are not replacing the wood we are harvesting. In countries like Canada and US, most of their buildings, the residential buildings, are built with wood, but they have ethical wood logging laws, right? There's something called forest stewardship certification, whereby there is, you don't just go and do indiscriminate logging. No, there are licensed companies that handle the logging and then the replanting, because if you don't replace, then you exhaust it and then there's nothing for future generations to use. Low VOC materials are also important, because it's one thing for a building to be eco-friendly, it's another thing for it to have a negative impact on the health and well-being of the users of those spaces. So when you're specifying materials, ensure that the materials have low VOC, especially sealants, paints, and woods that are used for interior finishes. Okay, so we can move to the next slide now. Energy efficient systems. So I always say, obviously we are all architects here, that the architect is the major, or they should be the main promoter of sustainable building practices, because it starts with you. Concept of the building starts with you, and you have all the freedom to apply as far as you can go passive design strategies. Because if we look at it now, with the way the economy is going, the cost of running buildings and all that, you realize that we have become so dependent on power, for example, for our buildings to run efficiently. If there is a power outage, all of a sudden there is this heat surge, all of a sudden you just become uncomfortable. And that's because we've become so reliant on active systems. So as architects, we should go back to the drawing board. Passive design is part of our educational curriculum. Orientation, shading, natural ventilation, thermal mass, daylighting. These are passive design strategies that if you incorporate into your design early enough, you find out that the performance of your building is enhanced and has less dependence on active systems. But peradventure, you're building up, you have to use some passive active systems. Then you now specify efficient active systems, especially regarding cooling, HVAC systems, and even our hot water supply. So the VRF systems, the energy recovery ventilators, putting smart thermostats and sensors, so that for public buildings, if there are no occupants in the space, the cooling system shouldn't be running non-stop. Water efficiency, we consider strategies like rainwater harvesting, gray water recycling, low flow fixtures, permeable landscaping. It's crazy. When I was coming back from Lagos recently, 2 weeks ago, and we were descending into Abuja, and I was looking at those estates to the left-hand side, that's Gwarimpa. while we are going towards the airport. And I saw how beautifully planned they were, the buildings, the fence, the roof, and then you would see interlock, no trees. And I don't know why the planning authorities or even building owners don't create any form of greenery, apart from the flower bed. Most of the plots, I know the plot sizes are limited, but then we can be creative about these things. Outside Nigeria, I know in Lagos, there's a building, I think the Randall Center, if I'm not mistaken, that has like green roofs. Green roofs are kind of other ways of us to augment for the footprint of our building. So if your project is if your project site is limited, then you can now incorporate greenery at the roof, and that also goes ahead to provide insulation for that building, reducing your cooling loads, for example. So permeable landscaping help you with runoffs, have rainwater harvesting. In Abuja, a lot of buildings have the rainwater collectors. Primarily, people put that to take water away from the building, from getting into the building foundation, but they channel it away to the gutters. And the main aim of the people that invented those things was for you to channel those water, collect those waters from your roof into a system, into a tank, either on the ground or buried under the soil, for you to reuse within your project. It could be for washing of outdoor spaces, it could be for landscaping, that's supplying water to the plants. It could even be for their systems, advanced systems, especially not for complex buildings that have a lot of wastewater. They harvest those water and then rechannel it into the WCs, for example. That way you're reducing your clean water demand. Renewable energy integration, solar PV systems, solar hot water, hybrid inverters, systems, and storage. So right now in Nigeria, I think there is the import tariff has been lifted for renewable energy. So the cost is gradually significantly going down. And I even read recently in the news that people are even beginning to see the payback of that investment, in the sense that by the time you calculate your investment of putting up the system as against what you would have been paying if you were using the grid, and especially if you were on band A, you find out that within a year, 18 months, you've already paid back or gained back the cost of that system. And then the rest of your energy supply is basically coming at zero cost. So architects should also find at the point of design ways to maximize renewable energy integration in the system. And you can do that even in you can do that in your reducing your demand. That is when you have maximize your passive design strategies using daylighting, reducing the insulation, reducing the cooling load. Then by the time you're transferring the rest of your active system to a renewable system, you will get a more sizable system. Because what people do these days is they transfer the load that would have been on the power grid to the renewable energy system, and you find them complaining, this inverter no dey work, this one no dey last, or you have to keep buying a lot of panels and a lot of battery for storage. So considering the active systems early enough in the design, once you're done with the passive strategies, and then adequate sizing of these things, it's not the architect's job. I know you work with the guys in charge of the renewable energy, but you can give them direction on how to go. Smart building technologies, building management system, Internet of Things, occupancy sensors, automated lighting control, etc. Those help us also to limit our consumption of electricity. Then there are two other points that I didn't add on the slide. So when you're trying to incorporate passive design strategies in your design, there are trade-offs that you often have to make. For example, you want to use natural ventilation, but what if the building is located in a noisy environment? So windows,
to family, to friends, to the community.
Someone's mic is on. Okay. If the windows are open, there's a lot of noise coming into the space, and that noise will give you your indoor environment becomes uncomfortable, and it negatively impact on your performance. For example, if it is an office space, then those are the trade-offs that you would now have to make. So instead of putting an operable window for natural ventilation, you put a window for daylighting and then supply something like ceiling fans for ventilation to give you that forced air movement for evaporative cooling. Then also the glazing systems matters. Yesterday during we had an edge expert training session, and one of the participants was asking why are curtain wall buildings not good? I said, well, it depends. There are curtain wall systems. I've seen triple, I've seen quadruple glazing systems. I've seen those systems that have inert gases in between. But at what cost do you want to have a fully glazed building? Except if the person is Dangote or $10, yes. But most people will want to get value for their money. And by the time you consider those passive design strategies, for example, orientation, we know the sun rises from the east and sets through the solar southern part. So you would now, if the building must have glazing, you position those glazing away from the direct solar radiation. You introduce those shading systems, right? Either an overhang, a fin, depending on the position of the glazing. You introduce low E coatings to the glass to reduce solar heat gain, as well as even the light, because if there's too much light penetrating the glass, you're also going to have glare, right? So the VT, that's the visible light transmitters factor of that glass, is also very important. I think that's that for under energy efficient system. We can go to the next slide. Innovative construction techniques. Yes. So under innovative construction techniques, basically, we have been doing what we have been doing and it's not taking us anywhere. So what can we do differently? We have the prefabrication, modular construction. What the benefits of prefabrication is that it reduces waste, it ensures faster delivery, quality control, and there's a cost predictability. And even the project that was done in Ghana, the sports center, I think the rammed earth was a prefabricated panel. So if you hear of rammed earth, you are thinking of forms cast in place and people doing the ramming of the compacting of the earth within the site. But I got to learn that even those ones were prefabricated and then installed on site. So prefabrication is not only for the advanced materials, we can also incorporate prefabrication and modular construction into our traditional practices. Adaptive reuse and retrofit. A building in existence is greener than a building yet to be constructed, even if it is green. So a brown building, meaning a building that is not green but has already been built, is greener than a new green building that is yet to be built, in the sense that there's no need to demolish and build a new building. You can upgrade the systems of existing buildings, and we can approach buildings that are no longer in use. Especially anytime I go to Lagos and I go through Lagos Island and I see those abandoned buildings, I always feel a certain way, because you can actually repurpose those buildings, right? Adaptive reuse and retrofit, upgrade the energy systems, introduce insulation or upgrade the envelope system as well as the facade system, and the building performance improves. So instead of demolishing that building and cutting it away to a landfill as waste, and then getting new resources to build another building, like the building that was demolished as a result of the fire, you can actually upgrade that system. But of course, there are structural retrofits that will be considered first of all, because safety first before sustainability, right? Green roofs and vertical gardens. So for stormwater management, thermal insulation, aesthetic value, and biodiversity support, green roofs and vertical gardens help are the innovative construction techniques we can look at. Then finally, climate resilient design, elevated foundations, flood mitigations, heat island reduction, very important. There's a heat stress as a result of increased deforestation and construction activities. We call it concrete jungles, right? So how can we make our buildings more climate resilient? It was on LinkedIn, I saw a video of a storm, and the building it had a mechanical system such that once the water came, the building lifted up, and after the floods, it came down. So those are innovative ways that innovation that we incorporate into our design to make it climate resilient. Next slide. So implementation strategies, integrated design process, very, very important. Early collaboration is key. Bring all the stakeholders. It's not just the architect and the design team. Who are the people that this project or the building is used for? Listen to their input and factor it in, and then have what we call design charrettes, where everybody sits together and you synergize. It's not when you go to site and you're having all those clashes and so many other disputes going on. And now with technology, you don't even have to wait until the building is constructed and completed before you do a post-occupancy evaluation. We have BIM tools, simulation tools that you can, whatever design decisions you want to take, you can simulate that project, and that way you save your clients money. I was hearing a story of a client that built, and after the building was completed, he had to sue the architect because he was like, why is my room so hot? Every time I come to sleep, the room is hot. And then the architect said, but you said you wanted your master bedroom to face this position, you know? And he was, but you should have told me that this is this part of a heat. And basically there was a lot of back and forth. So avoid all these things. We don't yet have those stories of litigation here yet in Nigeria, but then they could come up with very funny, notorious clients. Overcoming barriers. So there's the cost perception that if you want to apply sustainability strategies into your project, they are expensive. Yes, research has shown that the upfront cost is still below 10%. And if you do early collaboration, you do your sustainability charrettes, your multidisciplinary coordination, BIM integration, and all those things that often lead to what do you call them? Contingencies. You can see that even your contingency fee might be able to cover up for those costs, upfront additional costs that people think is a deterrent. And research has also shown that that upfront cost, you get payback for it. I've already given us the example of the solar systems. When you want to set up a solar renewable energy system in your house, you're going to cost nothing less than millions. If you're doing 5, 7, 15 kVA, it's tens of millions. So people are afraid of that upfront cost, but the payback period is there to give you savings. Financial incentives, there are green bonds, there are climate funds, there are PPP models, and ESG-driven investments. I'm sure as architects, we want to be busy designing. So if we want to be able to design, we need funding for those projects, right? So in implementation strategy, you can tell your clients or potential clients of the possibility of them to either raise finance through green bonds, climate funds, or other PPP models, as well as ESG-driven investments if they design green. I think that's the end of this slide. Is there another slide? Yes, so that's the end of the presentation. Key takeaways: sustainability is non-negotiable. Passive design is the most cost-effective. Local materials offer strong potential. Innovation must align with climate realities, and architects are change agents. Thank you very much for your time. And if there are any questions, feel free to ask them now.
Okay, thank you so much, Architect Mary, for your presentation. We actually have some questions which I would like to raise.
Okay, go ahead, please.
Okay, here, there's one. From the sustainability point of view, if you have to assess the integrity of an existing building internally and externally, one, what should you be looking out for? Two, what practical strategies would you adopt? Okay,
so first things first, the building has to be structurally sound before we talk of sustainability, because if it's not structurally sound, then the building, there's no sustainability to factor, right, to consider. So internally and externally, basically, if the building is in use, is the building in use or it's an abandoned building? I'll need that clarification, because you look at sustainability-wise, so you look at how you can reincorporate those passive design strategies. For example, if the building has been abandoned and you want to do a retrofit and upgrade the building, you look at those passive design strategies. So the building is already existing, so you can't do much about the orientation of the building. So what next can you do? Can you introduce insulation, especially to the roof and the glazing. Can you do that? If you can, then you factor those things. While you're doing that, you're looking at the cost implication, because it is one thing to check it on the box or on paper. It's another thing to fund it. So there are low-hanging fruits, and those low-hanging fruits, like I mentioned, EDGE certification tackles them. Energy efficiency, water efficiency, then material. So if the building is already existing, then you have already, that the first step is your decision to not demolish that building. Is already a sustainability decision, right? It's a sustainable decision that you decided, I'm going to retrofit this building, I'm not demolishing it. That is already a positive step. Then you look at how you can now reincorporate those passive design strategies first, before you now look at efficient active systems to support the design. I hope I've answered the first question. Can you repeat the second question? Or the second part of this question,
Okay,
please?
the second question, I think you also answered that. I said if the building is not in use, and what practical strategies would you adopt?
Okay,
That was
so
it.
I use the Edge tool. I know I'm going to be an evangelist for Edge, but I use the Edge tool because the Edge tool is, first of all, free of charge, and it's very easy. The interface is easy. You go in there, and what it does is that it gives you real-time feedback. So whatever it is, the existing scenario you have, the Edge standard is also achievable if you are able to show minimum 20% efficiency as against the baseline or the business as usual. You're already making positive impact, right? So I use the Edge tool for those things, and under the Edge tools, there are multiple measures. And the good thing about the Edge tool is that it also considers the cost of those green measures. So you're looking at, okay, this is a project, it is like an abandoned office building. Okay, I want to now upgrade it, probably convert it into accommodation or whatever it is. Then you model the structure as it is and look at what measures can I tweak. And because the Edge app it gives you live feedback. As you're putting this, you're getting feedback. Oh, if I put rainwater collectors, maybe you don't have enough roof space, for example. Then there's no point of spending a lot of money for rainwater collections. If you have a wide roof space, and for example, there's significant amount of rainfall that falls there, and there's water stress, I know there's a lot of water stress in Lagos, especially the island part, then you can now say, okay, let me introduce a rainwater collection and recycling system. Now, when you introduce that system, the app will factor in additional piping, because you're going to do your normal piping and then recirculate that water from the system back into your system. So there's a cost for going green, right? So I use the Edge app, and I would advise everybody, it's free of charge. Create an account and try and see how you can go around it. Thank you. Someone's hand is up.
I think we should, let me go through the questions first, please. Okay. Please, if you have questions, you can put them up in the chat box so we'll get them. There's one that says, how can architects interested in learning more about sustainability be part of the journey?
Okay, that's awesome. So part of the journey is actually what we're having today, a CPD session. Most professional bodies do continuous professional education system because there's always new things, innovation happening. So you need to keep yourself updated. There's a lot of information available on the internet. Then you can also enroll for any of the certification courses. In Nigeria here, Edge is more prevalent, but if you want to go a step further, you can do LEAD, you can do WELL or DJMB or any of the ones. It's important for you to have your goal, your target, and then decide to choose what is best for you. So you can reach out to your practice chair. I'm sure they have one or two things in the pipeline, and they will point you in the right direction. Thank you.
Okay, thank you. There's another question that I have here. How best can architects integrate green building practices in their design, especially when most clients are not aware of the role green buildings play in the society?
Yes, so you give them your role as an architect. You're not just it's just like a doctor. I go to a medical doctor. First of all, before I see him, I pay a lot of money. So when he's giving me advice, I listen, right? So you as the professional have to find a way of taking charge or being in control. And the clients must learn how to, so you find a way of transferring the benefits. what's the need for them. For example, I gave an example of the hotel project owner. I'm sure even though the architect then probably was also not very aware or conscious or did not intentionally recommend the sustainability strategies. But we have already seen that the benefits of green buildings are low operational costs. Who doesn't want to save money? Especially if that project is an investment project. You want to save money. So research has also shown that this cost upfront for is still below 10%. So is it not better for you to incorporate cry now and smile later? Because we don't know how the economy will go. Forex has become a bit stable now, but who knows, tomorrow it might go down or go up. So you would want to do what best you can at the construction stage, incorporating all those passive design strategies. Clients might frown and say, but you need to be firm, right? And tell them this is for your benefit. If I go to my doctor and he says he wants to give me injection and I say, no, I'm not taking injection. Doctor has sworn an oath to save life. He will give me that injection whether I like it or not. Thank you.
Okay, thank you. There's another question here. Different countries seem to be developing their green building initiative and certifications, e.g. the British and Germans. Are they all similar, and can we in Nigeria adopt any? Is there a need? Sorry, I think I lost that message.
Yeah, is there a need for any form of domestication? Yes, so domestication is important. Context matters. You can't compare a green building in America will look different from a green building in China. It will look different from a green building in Italy. It will look different from a green building in South Africa and Nigeria. Context matters, climate matters, construction practices matters, and then lifestyle matters. For example, in Europe, maybe their water use, their water culture, especially for shower, maybe 2-3 times a week. In Nigeria, it's at least once a day. So you are seeing that a green building, if you are using the water matrix for Europe, for Nigeria, it will make sense. So local context matters. Then even the power intensity of the grid, the carbon intensity of the grid matters. For example, there are countries that use coal. South Africa still uses coal to generate its electricity. So a green building, when you are using the energy matrix now to analyze the building, in South Africa will be different from a green building in Nigeria. I made mention of Nigeria's power coming from a renewable grid, but because it is not reliable, we have to back up with diesel generators. So you will find out that even our grid is having a little bit of high carbon intensity. Then lifestyle use, material use. So contextualization matters. Like I mentioned, there is the DGMB adaptation for Nigeria. I don't know if that's been launched or not. Nigeria, can we come up with our own? Yes, but it's very expensive to come up with your own. And then there are other systems that you can adapt. For example, the EDGE certification, in as much as it is a global certification, it is location specific in its assessment. So the base case building is a building in Lagos, business as usual, or a brown building in Lagos. And the improved case building or the green building that you're trying to design is comparing efficiency as against a local benchmark. So they've already done their research, collected data on our building practices, our building codes, if they exist or not, and they have fed it to the app at the back end. So you are using the EDGE app to certify a building in Italy or Poland. It will narrow down the climatic factors, the codes, and everything for that region. If you're using it for Nigeria, it will narrow down to Nigeria. If you're using it in Vietnam, it will narrow it down to Vietnam. So though it's a global certification tool, it still takes into consideration local context, which is very, very important. You can't uproot a building from one place and bring it here and make comparisons. No. So there are green building, international green building certification systems that are adapted to local context. Even the Green Star, which is, I think, Green Star came from Australia. It was adopted for South Africa, and there was a time they're also trying to do an adaptation for Nigeria. So you can't just take up those certification systems, because even LEED, 2 months ago, we were doing a LEED training, and you would see that even in their reference guides, they are telling you that you follow the US code, or for international projects, local regulations. So even those projects that were region specific are saying for international projects, do what your jurisdiction tells you to do. So that's it. Thank you.
Okay, thank you. There's another question. Thanks, Architect Mary, for the insightful presentation. Please, can you name any building in Lagos that has been certified? If yes, what certification was received? I didn't hear anything about waste management system. Doesn't this have effect on sustainability?
Yes, waste management system has effect on sustainability. Like I mentioned, other certification systems go a step further. But the reason why, like the EDGE certification I mentioned, they're looking at low impact, low hanging fruits for our regions, right? The regions where the main focus of this certification is energy, water, material. If you're able to make significant savings there, it is important. But that doesn't mean that you should go and do, you shouldn't have waste management system. No, it is important. In fact, it is to your benefit if your building is able to generate less waste, because beyond the building operations and the building maintenance, if you're having too much waste generation, it's also impacting on even your operational cost, facility management services, etc. So the first question was, is there a certified building in Lagos? Yes, there are many certified buildings. In Lagos, there's a LEED certified building. There is an EDGE certified building. Sterling Bank Towers in Marina is EDGE certified, and it was certified at EDGE Advanced. And if you see the building, it's cladded with BIPV. BIPV is Building Integrated Photovoltaics. So they wanted to incorporate renewable energy into their I don't know if it's the headquarters, but that tall building in Marina. And you see, it's a tower. They don't have enough roof space for them to install solar panels. And even if they install solar panels, it will not generate significant energy to run that tower. So their team came up with a genius idea of cladding the whole building with BIPV, and then they're able to generate significant amount of solar from that building integrated photovoltaics on the facade. So it's not necessary that the solar panel must be on the roof. No, you can put it on a car park. You can put it on fences. I've seen in Germany, they put it on fences, put it on the facade. And even now I've seen translucent glazing that also generate power. So technology is advancing. More advanced materials are coming up. I hope I've answered that question.
Yes, please. Thank you.
Thank
And they said, good day. What is the major challenge to implementing sustainability practices in the Nigerian context, and how can this be resolved?
It's a perception issue, as far as I'm concerned. It's a perception issue. And also, people are not ready to unlearn and relearn. This is the way we've been doing it. That's it. We don't want any new innovation and all those things. So you have to keep educating the clients, educating even the workers, educating even government policies. For example, Ramben Construction. I'm not sure if you carry your code, your building now to the planning authorities, and you specify that you're going to build it with C stabilized air brick, they may not flag it. I don't know if it has been approved like as a standard or incorporated into the building code, for example. So perception is a major barrier as far as I'm concerned for us in our context. Thank you.
Okay, we have a long question here. Let me go through it. Considering Nigeria's housing deficit and rising cost of rent, how can we realistically industrialize sustainable green tech such that it crashes cost for the average Nigerian today rather than years from now? The reality is that the specialized labor and supply chains to scale sustainable materials like rammed earth or low carbon concrete do not exist here, and in high inflation environments with double-digit interest rates, clients are focused on capex as they cannot prioritize OPEX savings when the initial construction cost determines if a project is even viable.
Yes, so CAPEX, OPEX, it is. I spoke about life cycle costing. Educate your clients. Yes, you're focusing on CAPEX, but this building you're building is going to last 60 years, 100 years. Prioritize life cycle costing when you're making decisions. Then regarding scaling sustainable green tech, it is the government that will bring in policies. I'm sure some of us online today are working in government. So we have to lobby, I guess that's the word now, lobby our way, even as a professional body, find a way of influencing certain policies that will move or kind of accelerate adoption of these practices. For example, even the housing deficit. So in our constitution, government is even supposed to provide housing for everyone. So if you don't have a house to stay, you should hold your government responsible. And because most of the materials are coming even from imports. Our almost everything apart from the cement, sand, and then one or two things that we get locally. Every other thing is imported from China, Europe, and all the other countries, fittings and all those other things. So governments must be intentional in developing policies, giving tax breaks to attract direct investment. So these people that are doing these things in China and all those places, they pay tax and all those other things in their country. So give them a better offer, let them come and make these things here. They are building the workforce, transferring skill, and then supplying the market is already existing, for example. Then even government must show example or leadership in the sense that their own projects, government projects, they should make sure that it is a sustainable project, not that you are saying one thing, oh, we are giving the policy, then when you want to build, your building is not anyway considering sustainability. No. So we need to also see leadership in the sense that public projects must also be sustainable project. And that's why I was very, very impressed when I saw the MOA Museum that was built with those sustainable materials and sustainable construction practices. So I hope I've been able to answer that question. Thank you.
Yes, please. Then the final question for the day. How can architects partner with the green building practice organizations?
Okay, so green building practice, I'm not sure there's a green building practice organization. So sustainability is a big umbrella, right? Sustainability is a big umbrella. Beyond building, sustainability goes into corporate governance, it goes into finance, it goes into everything. Is to get awareness and create, get the knowledge. Nigerian Institute of Architects Lagos State chapter, for example, has seen the need for this skill or this awareness, and they've created this platform. There is a Green Building Council. There are so many other sustainability, climate conscious or organizations out there. So it's knowledge now with the internet and AI is democratized. You can sit down today, go on ChatGPT and just have an interaction. Tell me about sustainability, tell me about what, in fact, give your real life scenario. You will get feedback. Then you go ahead and verify those feedback by looking at case studies. There are a lot of examples out there. So the people that initiated or conceived these things don't have two heads. You just have to be curious enough to want to be a catalyst of change and make the effort, and you'll be able to do it. But there are organizations, different groups that come up. UIA also has a sustainable, or is it the SDG arm? I know that there are information is out there. It's up to you to grab it and run with it. Thank you.
Thank you very much. Thank you for that insightful topic and presentation. I'm sure everyone has learned from it and would go back and try implementing all these things and convincing our clients to actually go green. Before I hand over to the Vice Chair to give the conclusion, I just want to point out that please, when we log in, we should always put our full name so it's easier for us to identify people that have attended. Thank you very much. Please, Actor Muniba, over to you.
Wow. Thank you so much. My goodness, this was a very, very insightful presentation. Wow, as architects, we must always take sustainability on the forefront of our projects. Like she said earlier, there are quite a number of projects in Lagos that are actually certified LEED, EDGE. If you really want to find out, it's actually just one question from an architect away. And as she said as well, in getting into the training of becoming a, practitioner, it's actually very easy as well. You just need to reach out to one or two people and you will get on the train. I have learned so much. I remember when I was building a certified area about this, where you have a client that says, "Oh, I want to be LEED certified," or "Oh, I want to be EDGE certified." That makes the design process all the way from that much easier. Thank you so much, Architect Mary. Thank you so much, everyone. To reach out for her presentation. It will be sent and eventually posted on the website for your download. If you have questions, you can always send it to either the GS or myself, and we'll definitely to the right person to resolve it. I want to take the time to thank everybody who took the time out to join this presentation today. All our fellows, our full members, everyone, please. I really enjoy the fact that our CPDPs are gaining traction. Please spread the word. We are putting in a lot of effort to bring information, awareness, and advocacy to our chapter members. The presentations and the CPDP lectures are also available on our YouTube page. So please, if you missed it or someone you know missed and really wants to, please feel free to check on our YouTube page for the playback. Thank you so much, everyone. Remember that we have our meeting with Mr. President at the end of the month. You'll definitely get notices prior to that time. I hope you all had a great time today. I definitely did. Thank you so much for the time.
Yes,
GS, if there's any other information,
yes, please. Yes, I also
go ahead.
you can also check our YouTube page for this, a copy of all our CPDPs are there on demand. So you can always go back to listen to every one of our CPD programs. Thank you very much again. And we look forward to seeing you at our next business meeting.
Thank you, everyone. Have a good evening.
Goodbye.
Goodbye, everyone.